بسم الله الرحمن الرحيم. The last part we spoke about the definition of matrices and we gave some examples about the addition of two matrices, equality of two matrices, and scalar product or multiple of a matrix. And also we stated some properties of the addition of the matrices. In this part we are going to speak about the multiplication of two matrices and also transpose and symmetric or symmetric and symmetric matrices. So starting with the matrix multiplication. See that if we have two matrices, say that let A be a matrix having M rows and B columns. And B, capital B, matrix having B rows and N columns. Then the product AB is the M by N matrix. Given by AB K equal to 1 up to P of A I K B K G. M by N. See what the meaning of this statement. I have A with size M by P and B with B by N. The necessary condition for the matrix multiplication that the number of columns in the first matrix equal to the number of rows in the second matrix. This must be equal. If the number of columns is not equal to the number of rows in the second matrix, then we cannot multiply the two matrices. This condition must be there. Number of rows of A equal to the number of columns, number of columns of A equal to the number of rows of the matrix B. This must be there. And the result will be a given matrix C. This I cancel the B and B, I will get M by N. This will be the new matrix. This is the idea of the product of two matrices. And if A is given by, let's say, Aij up to, or say 1, 1, up to A1, first row, up to column B. This is the matrix A. And if you want to multiply it with the matrix B, that B 1, 1 up to B1, n columns. Going down up to B1 up to Bn. The matrix multiplication is to multiply the rows with the columns. This will give me the first element. It's going horizontally. This row multiplied by the column. To explain this with examples. Let A is equal to 4, 7, 3, 5. And B is equal to 9, minus 2, 6, 8. Find 1, A, B. See the size of the A and B. This is 2 by 2, and B is 2 by 2. These are equal number of columns equal to the number of rows, so we can apply the matrix multiplication. This condition is satisfied. Number of columns in the first matrix equal to the number of rows in the second one. Now to multiply A times B. A is given by 4, 7, 3, 5, multiplied by 9, 6, minus 2, and 8. Horizontal, then vertical. So the multiplication of these two matrices will give me 4 by 9 plus 7 by 6. First one with the first one in the column, second in the second. And we add them. This will give me the first element of the matrix. Now let's move to the second column, this one. The same row of the first matrix with the second column will give me 4 times minus 2 plus 7 times 8. Again, multiply the first element in the first row with the first element in the second column, and the second element in the first row of A with the second element in the second column for the column B. Do the same thing for the second row. I have 3 and 5. So I will have 3 multiplied by 6 plus, sorry, 3 by 9, not 6 by 9, plus 5 multiplied by 6. Now move to the second column. 3 multiplied by minus 2 plus 5 multiplied by 8, which is equal to, we have 36 plus 42 is 78. 4 times minus 2 is minus 8, plus 56 is 48. 3 times 9 is 27, plus 30, 57. Minus 6 plus 40 is 32. So this is A multiplied by B. Row multiplied by columns. Now let's find 2 B times A. Check. Let's find B times A. So this should be 34, not 32. 34. Now B times A. Let's repair the order. 9 minus 2, 6, 8. Multiplied by A is 4, 7, 3, 5. Which is equal to 9 multiplied by 4 plus minus 2 times 3. Row with columns. Second one, 9 multiplied by 7 plus minus 2 times 5. Second column. The second row now will give me 6 times 4 plus 8 times 3. Now second row with the second column. 6 multiplied by 7 plus 8 times 5. Which is equal to 9 times 4 is 36 minus 6 equal to 30. 9 times 7, 63 minus 10 is 53. 6 times 4 is 24 plus 24 is 48. 6 times 7 is 42 plus 40 is 82. Now let's see, compare between these two matrices. I have B times A equal to 30, 53, 48, and 82, and A times B equal to 78, 48, 57, and 34. So we can see that from these two products that A times B is not equal to B times A. So the multiplication with the matrices is not commutative. A times B is not equal to B times A. So it is not commutative. One more. Let's find A square. Number 3. A square is A multiplied by A. It's A times A. Which is equal to 4 times 4, 7, 3, 5 multiplied by 4, 7, 3, 5, which is equal to 4 times 4 and 7 times 3. Second one, I will have 4 times 7 plus 7 times 5. Now the second row will give me this one with 4. It's 3 times 4 plus 5 times 3. Next one is 3 times 7 plus 5 times 5, which is equal to 16 plus 21 is 37. And we have 4 times 7 is 28 plus 53 is 63. 4 times 3 is 12 plus 15 is 27. And 3 times 7, 21 plus 25 equal to 46. So from this one, A square doesn't mean that we square every element of the matrix A. And we can see this is not equal to the square of the element, that is 16, 49, 9, and 25. So a square or a dot a or a multiplied by a doesn't mean to square every single element of the matrix A. It is not correct. We have to be careful about the power of the matrices. So this is the idea of multiplication of matrices A times B or B times A. Changing the order will not give me the same answer of the product. A times E is not equal to B times A, and A square is not equal to the square of each element of the matrix A. Next point, think about the transpose. Of a matrix. The transpose of matrix A is given by AJ M by M is the matrix N by M. And denoted by AT. In some textbook is given as A dash. But we are going to use A T or power of T. This means transpose. Given by A T equal to AI N by M. The element of the matrix A is given by IJ. This is JI. Means we are reversing the order, making the column equal rows or rows the column of the new matrix. For example, let A equal 3, 4, minus 5, 6, 7, 8, minus 1, 0, 2. This is of size 3 by 3. Matrix. Now the transpose of this one AT equal to, it will be 3 by 3 also. But this is n equal to m, it is a square matrix. But the transpose means we are converting the rows to column. It will be 3, 4, minus 5. Second one, 6, 7, 8. The row is becoming column. Minus 1, 0, 2. So this is the transpose of the given matrix A. Changing the rows into columns. One more. Let B equal to 2, 4, 4, 5, minus 1, 9, and say 10. This is of size 2 by 3. The transpose B is equal to, it will be 3 by 2. This is 2 by 3. The transpose will be 3 by 2. Now the row 2, 4, 5 will be written as a column. So it is 4 or 2, 4, 5. Minus 1, 9, and 10. So this is the transpose of the matrix B. Changing the rows into columns or columns into rows.